Hey guys, welcome back to my YouTube channel, and it looks like we are gonna do all of embryology on this channel, but for this video we're gonna talk about development of the kidneys. Obviously gonna go through everything that is there in the MBBS textbook of IB Singh, and then of course go through what the first year has mentioned. So as I usually do, I'm gonna give you a preview of what has happened until we can talk about development of kidneys. So of course we have our zygote, morula, blastocyst, bilaminar germ disc, trilaminar germ disc, right? And then we get the formation of the notochord, which is there in the mesoderm. That helps in the formation of the neural tube in the ectoderm, which invaginates and then comes to lie in the mesoderm. And the mesoderm around the notochord differentiates into paraxial, intermediate and lateral plate mesoderm. And urogenital system is derived from the intermediate mesoderm. We only discuss about intermediate mesoderm when we're talking about development of the kidneys, ureter and all, or we're talking about the gonads. So urogenital system, only intermediate mesoderm is responsible for it. So that's the preview before folding. Now so this is before folding, right? This is the intermediate mesoderm here. So after folding, what happens? If you've seen the mid-gut video, so if this is your embryo, for example, that's a very bad embryo. This is your embryo, for example. This is your gut tube, right? And you'll have a vitellar intestinal duct and the yolk sac and everything. So what happens is the intermediate mesoderm forms our urogenital ridge. So I'll write it down. Urogenital ridge. Okay, so this is the urogenital ridge. It has two parts. Medially it will form your gonads, and laterally it is called as the nephrogenic cord. That means it will help in the development of the kidneys. So this nephrogenic cord, or you could say urogenital ridge, develops on either side of the gut. The gut is attached to the posterior wall by a mesentery. So on the either side of that we have the nephrogenic cord. That means we have two in number because we have two kidneys, obviously. So again, if this is the embryo, we have the gut tube here. We have the nephrogenic cord, one on each side, laterally to it. So it extends from the cervical region till the sacral region. Okay, and at different points it differentiates the different stuff, and eventually we have our adult kidneys. So that's all about the preview. I'm talking about the main topic. So development of kidney, what is important to know is that, for example, so you have your kidney, right? So it has your pelvis here, the major calyces, the minor calyces, and then you have your cortex and the medullary medulla, right? If we go even more microscopic, we have our pelvis, major calyces, minor calyces, collecting ducts, DCT, loop of Henle, TCT, and the glomerulus, right? So all of this, that is the collecting ducts, major and minor calyces, the pelvis, and even the ureter, comes in the excretory part of this developmental process, and this comes in the secretory part. That means the nephrons. So what happens during the development is the secretory part develops from one thing, the excretory part develops from other thing, and they both join together, or basically they derive from different things. They don't develop together. So kidney is developing in two parts, excretory and secretory. So that is another thing you have to know before we get into it. The third thing which you need to know is this: ontogeny repeats phylogeny. I'm pretty sure you've heard about it once in NCERT for NEET prep. So what it means is, obviously we know the younger, or the more underdeveloped or the primitive members of the animal kingdom, they have a pronephric kidney. Slowly it developed into a mesonephric kidney, and we humans, we have the metanephric kidney. But as an embryo, during the development, we go through all the three types of kidney. That means we have a pronephric kidney for some time, then a mesonephric kidney for some time, and then finally a metanephric kidney forms, which is permanent and is there throughout our life. So that is also something you need to understand. Last thing before we actually get into the video is this. So we have our midgut, hindgut, all of that. The part of the hindgut which is distal to the allantois is called as the urogenital sinus, okay, or it is called as the cloaca. All right. So cloaca, when you see it ventrally, you'll have the urogenital sinus. Dorsally, it will form the rectum. Okay, urogenital sinus. So there is a septum. For example, if this is a cloaca, there will be a septum in the middle dividing into a ventral and dorsal part. Ventral is urogenital sinus, dorsal is rectum. That urogenital sinus is divided in two parts, which is the vesico-urethral canal and the definitive urogenital sinus, which is this. This was the primitive urogenital sinus. This is the definitive urogenital sinus. So at the junction of these two is where the mesonephric duct arises from. That is why I wanted to mention it, where the mesonephric duct is going and attaching to the cloaca. So yes, that's all. Now we get into the actual development of the kidneys. So as I said, throughout the embryo, nephrogenic cord develops somewhat like this. Okay, you have your gut. So they have only shown one side. You obviously have both the sides. So the cervical region of the nephrogenic cord develops into pronephric tubules. So you have these pronephric tubules. Along with that, what develops associated to these pronephric tubules is a nephric duct. So this is a nephric duct. It goes and opens where? Cloaca. Where in the cloaca? At the junction of vesico-urethral canal and the definitive urogenital sinus. So pronephros, or the pronephric tubules, they don't function as the kidney. They develop in the embryo, they are there for a very short time and then they degenerate. But even while they are existing, they do not have any function. They just come and go without actually being useful. So they degenerate, and at the same time when the pronephric tubules are coming, the mesonephric tubules also start forming. So this was in the cervical region, so a little more caudal to that, the mesonephric tubules are formed. So even these join the duct. Which duct was that? We were calling it the nephric duct, right? Now we call it the mesonephric duct. So we have the mesonephric tubules and the mesonephric duct. Okay. Contrary to the pronephric tubules, the mesonephric tubules are actually functional. That means they form an interim kidney for some time and then they also degenerate. So we can see here the pronephric tubule, it's degenerating. Mesonephros and pronephros, they are also degenerating. So here you can see how the mesonephros actually is. We have the mesonephric duct, the mesonephric tubules, and the blood vessels from the dorsal aorta. So you see, this is not actually as well developed as the kidney we have in our adult body, but it has the basic functional unit, which is kind of similar to a nephron. We have a tubule and we have a blood vessel. So this functions as a kidney for some time and then obviously it regresses. Next is metanephric kidney. So as I told you, different parts of the nephrogenic cord give rise to different things, right? So cranial part gives pronephros, then mesonephros. So the sacral part, or the caudal most part of the nephrogenic cord, gives rise to the metanephros or the metanephric blastema, also called as the metanephric mesenchyme. So it is basically a mass that appears. So one may ask how it appears. So as we discussed in the arch of aorta video, the pharyngeal arch arteries, they don't appear. There are a lot of things that are happening at the molecular level. There are growth factors and everything that is leading to the vasculogenesis. Similarly, there are also a lot of things are happening on the molecular level, but obviously that's too much detail and we don't know. For now, we just go with the idea that it comes to appear out of nowhere. So that is a metanephric blastoma. Next thing that happens is a ureteric bud comes from the caudal part of the mesonephric duct. So this is the mesonephric duct. The caudal part of the mesonephric duct has this bud coming out. So this is called as a ureteric bud or a metanephric diverticulum. Okay, so you have your ureteric bud and you have the metanephric blastema. Now what happens is the differentiation of these things. So now we go to which diagram? This one. So the ureteric gut met the metanephric tissue, then it starts dividing into various generation of the branches. Obviously the part which is caudal to this, that forms the ureter, right? Then here it divides. Initially we get the pelvis, then we get the major calyces, then we get the minor calyces. So at the end of the ureteric bud, it forms somewhat like an ampulla. Not required, but when it comes to contact with the metanephric tissue, it basically promotes the differentiation of the metanephric tissue close to it. So then the metanephric tissue starts differentiating into forming the secretory part. The excretory part is formed like this: the ureter, pelvis, major calyces, minor calyces, and the collecting ducts finally. Then this tissue starts differentiating to form our secretory part. So how does that happen? Here it is. Again, this is too much detail, not required, but we'll just read it out. So eventually it's the stage of interaction. Both of those interact. Ampulla is formed, then cap stage, no need. So basically different changes are happening. Blastema is forming, vesicle is forming, comma shape, then S shape, and eventually we have a nephron, right? With the Bowman's capsule, PCT, loop of Henle, DCT. And obviously from the blood aorta, you are also getting your arteries or afferent and efferent arteries and all of those things. That's not actually a part of this. So it's this is how both the parts are developing. First the excretory part and then the secretory part, going through various stages, and that's how we get our adult kidney. But that's not it. As we discussed, the metanephric kidney is forming at the caudal part of the, coming from the caudal part of the nephrogenic duct, as we can see here, which is where in the sacral region. Are our kidneys in the sacral region? No, they're in the lumbar region. So after the development, what happens is the ascent of the kidneys, like this. So they eventually ascend upwards into their adult position, and again there's no need to know how it happens, the differential development of the wall and all, but here also many things can go wrong, leading to abnormal position of the kidneys and everything. So all you need to know is at the end of the development, the kidneys ascend from the sacral region and eventually to the lumbar region. So that's basically everything there in the textbook for the MBBS IB Singh. Now talking about the first aid. Quickly gonna revise, we've already discussed everything. The only thing I did not mention is two, which I'll let you know. First is the date or the timing. So Pronephros comes in the week 4 of the development, then degenerates. Mesonephros, same time, functions as the interim kidney for the first trimester. Now what I did not mention is this. So the urogenital ridge has two parts, right? The one which forms the kidneys and one gonads. But a part of the nephrogenic cord also forms the duct system of testis in male, obviously. So what happens is, these are the mesonephric tubules, right? They degenerate, but some of them are left out. The left out mesonephric tubules form the duct system of the testis. That means the epididymis, the ductus deferens, Wolffian duct, all of that. Okay, so that is there in the male. In the female, there is something called as a paramesonephric duct, but not gonna go into that right now. So that is what they've said here, that it persists in the male genital system as Wolffian duct, forming ductus deferens and epididymis. Metanephros, permanent, appears in the week 5 of development and completed by week 36 of gestation. Then we have the metanephric diverticulum, derived from the caudal end of the mesonephric duct, gives rise to the ureter, pelvises, calyces, collecting ducts, fully canalized by week 10. So these dates are what are not mentioned, right? Week 4, week 5, and then completed by week 36, and this completed by week 10. Now, metanephric mesenchyme, ureteric bud interacts with this tissue. Interaction induces differentiation, formation of the glomerulus through to DCT. And that's about the normal development. All of this is not, it's pathology and the aberrant stuff that happens, so different video for that. So that's all for the development of kidney. I hope I made it easy for you, and I'll see you guys in the next one. Bye.